Hey everyone, Bob here. Today I would like to present to you my prime power generator set preventive maintenance program. And this is a comprehensive one. As you know, I have presented to you the preventive maintenance program for the heavy equipment which I have created before. And this one is going to be about generator set. Why prime power generator set? There are two applications of generator set. One is the prime power generator set, and the other is the standby power generator set. Standby power generator set is intended for, a standby unit only, as the installations or the organization is connected to a commercial grid or a government grid power source. Some organization or some installations prefer to use the prime power generator set because they want 24/7 utilization of the power and a reliable one source of power generation. Okay, like for example, military installations where they're having a radar operations for air defense operation center where they utilize their own radar and utilize their own power generator set. The power generator set is installed for each radar that they have and make sure that they have a reliable source. Unlike if they are connected to the government grid, where sometimes the grid is unreliable, and some countries are having problems when it comes to power outages. So this is a good strategy in maintaining, like military airbase where they have their own source of power generation. Okay, so that's the difference between. So what we're going to do is I'm gonna stick to the prime power generator set. Although we're comparing to the standby set, the power output in terms of the kVA or kilowatt or megawatt is a bit lower compared to the standby unit set. Okay, so I have included here some portions of the presentations where I'm gonna explain to you later. I'm gonna work you through to these portions like job order, the PM, preventive maintenance plan, the job data, job history, the job type of the work that we're gonna be doing in terms of the preventive maintenance. Then I have included the CMS means corrective maintenance system job. Then I have included the major repair whenever we'll be doing job repair activity for the generator set. Then I have some example here for our generator set, which I've written here, the master list of the generator set sample that I have that we're going to use in our program. Then the staff, which is the mechanics and the electricians. Then the work instruction. This is the SOP, standard operating procedures, work instructions, work procedures, work methodology, and safety precautions to make it, for individual to be safe and for the unit generator set to be safe. No damages no damages happen during the performance of the preventive maintenance program. Okay, let me start by looking at the job order here. This is the job order that I have created for you guys. Okay, the content of the job order is specifications of the unit, generator set, the job type, the service type. You also have the job number and the date of performance of the job. Then the item that's going to be, maintained, like let's say for example, water pump, turbocharger, oil pump, fuel pump, etc. Then the work description, what is the job that is going to be carried out, like checking, top up, overhaul, adjustment, inspection, etc. Okay, and look here. This is the mechanic that we're gonna assign. There's a staff number and the name of the person, and then also an electrician. Majority of the maintenance is involving mechanical work, and that's why we need more mechanic rather than electrician. But there are also electricians concerning the repairs of the controls, the like the oil senders, the temperature senders, the sensors, the harness, wire harness, and other components like starter motor, charging system. Okay, so we're gonna have electrician as well, and then of course we only have one operations manager is going to approve the work order or the job order, and we have here a staff number, and name is Gregory Black, which is a permanent fixture here because there's only one operations manager unless the company decides to replace this guy with another guy, for some issues, for example. And so I made it permanent here. And then we got three job types that we are having. One is the PMS, Preventive Maintenance Servicing, Preventive Maintenance Program. Then the other one is the CMS, Corrective Maintenance Servicing, or the breakdown, repairs, things like that. And the third column is the MR, Major Repair or Major Rehabilitation, Rehab, or Refurbishing. Okay, I have assigned some code here for the specific job that we're gonna be doing. Under the PMS is the P1, P2, P3, P4, all the way up to P36. Okay, it could be longer, but in this case, in this program, I have designed specific jobs for the preventive maintenance programs up to 36, and the CMS corrective maintenance programs, C1 to C16. This is more of a repairs, corrective maintenance, shutdown maintenance. Okay, unlike the preventive maintenance, which is really planned and scheduled, the corrective maintenance is unscheduled. Okay, the preventive maintenance is like this is a proactive maintenance. Shutdown is scheduled. Shutdown schedule can be arranged with the end users, agreed with the asset end users. End users could be the supervisor or the managers of the operations of the power generation system. He could be the operator of the radar or something else. In the manufacturing or in the industry, where they also have the supervisor or the manager running the business, who is the end users of the power source or the power generation source or unit. Okay, so thereby be able to control the downtime factor to the lowest. Okay, if you have preventive maintenance, you're gonna prolong the service life or the span or the utilization of the unit. Because you're doing preventive maintenance, you prevent any untoward incident or untoward the sudden breakdown of the unit. Thereby it affects the downtime factor of the unit, and it affects the useful to the operation of the what the power generator set is intended to do. So that is prevention, or you may call preventative action. Okay. So management will also be able to put a scheduled preventive maintenance plan in place. That's very important. Scheduling, planning, and scheduling program. Management will plan for the financial budget. Very important, because when you're doing preventive maintenance program, you should have inventory stock, like spare parts, like oil filters, fuel filters, air filters, oil, and some other things, that you have to put in stock, because you're gonna be doing scheduled maintenance for the next 6 months or the next 1 year. So inventory of stock of spare parts and materials can be planned and will also affect the working capital or cash flow in a positive way. Okay. So because you're maintaining your cash flow, you're maintaining your working capital. So that's why very important that you plan well in terms of the procurement of spare parts and materials. Okay, so let's go. Let's continue. So I'll show you the PM plan. This is the PM plan. These are the things that we're gonna be doing in terms of the PMS, preventive maintenance servicing. Okay, so we got the work code here that I've explained to you earlier, all the way up down to P36. And there are items that they're going to be doing, like engine assembly, generator assembly, inspection, and walk around, check. If you're doing maintenance, you are going to walk around the unit, and they're utilizing huge unit like 16 cylinder, 20 cylinders of huge engine, diesel engines, four-stroke cycle engines, like the coolant level, electrical connection, check, check, clean, top up, etc. And then the frequency of the service plan, you have daily plan, you have 50 hours, 50 hours 1 year, or 1 year, 2,000 hours or 1 year, etc. Okay, these are the things that we're gonna be doing under the PMS. Okay, so let's go back to the job order. So this is okay. So these are the things that we'll be doing, and again, go back to the dashboard. Okay, I have already explained to you the PM plan, and then I'm gonna explain to you the job data. The job data is the history of the job order. Every time the maintenance manager is doing job order, or the maintenance department is generating a job order for the implementation of maintenance. All of this job order will be reflected here as history, and all the information, job order, date, generator set, make, model, service hours, service type that the mechanic is gonna be doing, item description, work description, the name of the mechanic, the name of electrician with stop numbers. All right. So every time we generate the job order, it will be reflected here automatically. Okay. So we go back to the dashboard. Okay. So that would be the job data or the job history. And then we got the job type. The job type is the one that I was talking about. Okay, I can explain it one by one, row by row. Okay, we start with the P1. I'm gonna highlight it. Engine assembly is inspection, workaround, check for something, something wrong with the engine, like oil leaking. Some guards are not, installed, or loose, or something else. Okay. Then same thing goes with the generator assembly, inspection, workaround, check, look for the controls, look for things that is wrong, So that is inspection. The P3 is about coolant level, check and top up. P4 is about electrical connections, check. This is gonna be gotta be performed by the electricians of the, you hire an industrial electrician and his expertise on generating sets power units. Okay. Then air cleaner service indicator. The indicator, it shows red or green. Red means the air cleaner is clogged up, full of dust inside that needs cleaning. That's why it's showing you red indication. You have to inspect and clean with air coming from the air compressor, something like that. And then also the element, you're gonna check and clean it. Then next one will be engine oil level, check and top up. Fuel system primary filter, check. Fuel system water separator, check. Fuel level, check and top up. Generator load, check. Fuel tank, drain water condensates, alternator, inspect. This is the charging system of the engine. Okay. The generator winding insulation, going the chest, test it. Then coolant sample level 1 obtain. Engine oil sample obtain. You know, we are getting samples of the engine oil every time where the mechanic is doing an engine oil change. Is going to send it to the laboratory for testing and looking at the condensates, looking at the contamination, looking at the fuel sulfur. You know, diesel fuel are also, you know, passing through the piston ring, and it mixes with the oil in the engine oil sump or engine crankcase or engine pan. And usually, in my experience, maximum of fuel sulfur should be around 1%. If it is 1% and less, that would be okay. That would be good. So maintain the frequency of the changing of oil. If it's more than 1%, that is already bad, and you have to, you know, something is wrong with the piston ring, maybe sticky, and some blow by is happening in the piston through the piston ring and going into the oil sump, mixing with the oil. So you need to, you need to get some samples, and that is what this job is all about. And also the coolant sample level to obtain. Engine valve flush, maybe it needs check or needs adjustment, but mostly this kind of engine are hydraulic. The valve flush are hydraulic, but it's, you need to, sometimes it gets loose, and you need to adjust it to 0 clearance. Battery electrolyte level is gonna be done by the electrician. And belts, inspect, adjust, replace. Engine air cleaner element, you know, engine crankcase breather element replace, engine oil and filter change, fuel system primary filter water separator element replace, fuel system secondary filter replace, hoses and clamps inspect slash replace, engine valve flush check, rotating rectifier is going to be done by the electrician of the generating set. The alternator inspect, engine mounts, sometimes because of the vibration, the engine mounts get loose. You have to inspect that, tighten up some, bolts or fastener. Starting motor inspect, turbocharger inspect, water pump inspect, coolant temperature regulator replace, coolant add, coolant extender change, dry belts replace, water pump repair or replace, radiator overhaul. It's already clogged up, clean. You need to clean it. You need to clean with steam cleaner. You need to clean with, they don't use, high pressure cleaner because it will damage the fins of the radiator. They only use a steam cleaner for this, and replacing of the thermostat. Engine alternator overhaul, replace brush. Engine starter motor overhaul, replace Bendix drive, replace brush. Cylinder head top overhaul, grind valves replace, head gasket. Turbocharger overhaul, engine flywheel replace. Fuel pump repair or replace. Blower, this is for Detroit diesel Allison engines overhaul. Injection pump overhaul, recalibrate. Fuel transfer pump overhaul, replace. Fuel injectors, oil pan, leaks, heat exchanger, engine assembly, alternator assembly, engine assembly, generator. Okay, this is for the PM1 to the P1 to P36. Okay, and the second set is for the C1 corrective, corrective maintenance servicing, C1 to I think C16. Then after doing this is the corrective maintenance, the shutdown maintenance. This is different from the P1 to P36, which is preventive maintenance. And then the last portion of the job type is the M1, M2, M3, M4. This is the major repair or major rehab. For the engine assembly, you need to overhaul. Alternator assembly, rewind. Engine assembly, you need to do a dynamometer test. Generator needs to brine test procedure. Okay. So what is the purpose of the dynamometer? Dynamometer is to find out the brake horsepower after the engine was overhauled. You need to find out whether you are able to get the required brake horsepower, and the engine torque. Okay, that's why you need to do the dynamometer test. And then for the next one, the M4 is generator set. This is the prime test procedure. You're gonna be, after rewinding the generator set or the alternator, you need to brine test procedure. The brine test is like, the engine assembly is, being tested in a dynamometer, and then it will be coupled with the generator set. When the generator set was already, rewind was done on the generator set, then you couple the engine assembly and generator set. Then you run the engine. After running the dynamometer, you run the engine by doing the brine test procedure. What is brine test procedure? This is some kind of tank where you fill with water and salt. Okay, that's why it's called brine. This is for the load testing of the generator. There are three phases. There's three phases in the generator. The bus bar. You're going to submerge the bus bar while the engine is running, dynamometer is running, the generator is running, and then you'll be able to test the load test. Okay, like for example, if the generator is 2,000, having 2,000 kVA capacity, then you find out whether the engine will be able to supply the required horsepower and the torque to be able to for the generator to supply the power that is needed, which is 2,000 kilovolt amperes kVA. So this is the purpose of the brine test procedure. Going back to the dashboard, okay. So that would be the job type, the the CMS like this one. I have already given this, but I'm gonna show it to you. The corrective maintenance service shutdown is the same as I have presented to the job type, but this one plus the diagnosis of the failures. Why we're doing dry belts replace? Because it's cracks, plates, glazing, grease, broken ribs. Water pump repair or replace because the engine overheats, cracked cylinder heads, piston seizure, loose impeller of the pump, radiator overhaul. Why this is being done? Because of the engine overheats, again, cracked cylinder heads, piston seizure, clogged cores, coolant thermostat replaced because of the high engine coolant temperature. So all of these are happening. You're gonna be doing the corrective maintenance servicing or the shutdown or the repair because of this diagnosis or the failures of the components. That's why you're gonna be doing for this item description, you're gonna be doing this kind of work under the corrective maintenance service shutdown, okay? Also, same thing with the major repair. So you got the M1 is work code, engine assembly, major overhaul. Why there is a diagnosis also? Why it's being, this is different. The CMS and the MR is different from the PMS. The PMS is a scheduled maintenance. Whether the component is damaged or not, still going to be doing the PMS to prolong the utilization factor or the useful life of the unit. So why are you doing engine? Maybe you're doing the overhaul because of the power loss, overheating of the engine, excessive oil and fuel consumption, or blow by, or pumping oil, or etc. As for the alternator assembly or the generator, does not reach peak power, meaning it's very low, not able to reach the peak power that is needed to supply the kilowatt, the megawatt, or the kilovolt amperes. Okay, so that's why it needs to be rewound or rewind. Activity will be done for the alternator assembly. That is a major repair also. I have included here the M3 engine assembly dynamometer test. Overhaul completed. Need to find out whether it will reach the required brake horsepower. Brake horsepower is the actual horsepower that is, given in the output. The output of the crankshaft on the flywheel. So you will know that after having the overhauling of the engine, and doing the dynamometer test and able to get the brake horsepower and engine torque. If not, then you have to do some adjustment. It's something wrong in terms of the fuel timing, in terms of the valve adjustment, the fuel injection, etc. So you have to find out. That's why you need to do the dynamometer test. Then the last one would be the generator. The blind test procedure that I've explained earlier need to test the genset to at full load. So there are only 4 items here in the major repair. There are more items in the PMS, which is here, the PMS, preventive maintenance service, and less items for the corrective maintenance service, and the list item for the major repair M1, M2, M3, M4. Going back to the dashboard, okay, so I have explained to you, the major repair and the master list. These are the things that I have in the master list. This is an example of the genset that I have here. I have numbered it GS01 to GS20. And these are the engine makes, mostly a Caterpillar. These are more popular than the rest of the make, but quite expensive. Buying Caterpillar is quite expensive. Unlike if you buy, Korean made, China made, or even Japanese made generators is a lesser amount. So the acquisition cost is more in terms of the if you are purchasing Caterpillar. Then the model and the cylinders like B16, B12, things like that. If there is even B20 here, or 20 cylinder, okay, the horsepower, the RPM, revolution per minute. When you talk about 50 hertz, 50 cycle, usually the revolution or the RPM is 1500 RPM, and for the 60 hertz or 60 cycle, it's usually 1800 RPM, and there's some exception though. No, when it comes to aspiration, the generator or the engine, it could be TA, turbocharged after cooled, or TI, turbocharged intercooled. For Caterpillar, they're calling it after cooler. Then, but the Detroit Diesel is calling it intercooler. But the same purpose. The purpose is to increase the density of the air that's flowing through, going into the pistons, into the combustion chamber for the purpose of efficiency in combustion, to get more power, to be able to generate more horsepower. You need to have turbocharger, especially if in the area where the air is thinner, like in the hilltop or in the mountainous area where the air is thin, density is less, where the pressure is less, in the sea level area, the pressure is 14.7 psi, usually like that. Then if you go higher in the mountain, the air is pressure is less, the density is less. You have a thin air like that. That's why they always use turbochargers. But anyway, almost 100% of the generator, especially the big one, are always having turbocharger. But they added the intercooler or the aftercooler, to increase the density of the air flowing from going through the air filter, going into the piston for combustion purpose. So you need more air. So the cooler the air, the more density of the air, the cooler. That's why they're cooling the air. Okay, by the air going through the after cooler or the intercooler. Then you get the KVA. I prefer to call it KVA rather than the kilowatt or megawatt. Okay, so KVA is usually for engineers. Their terminology used is the KVA, more convenience for us. In terms of the voltage, you have 480 volts, 400 volts, 380 volts, and the hertz there are only 2 hertz, 50 hertz, and 60 hertz. Then you got service hours. For every generator, there are hour meter where hours are indicated. So, when you're doing preventive maintenance program, planning and scheduling, you base it on service hours, And the last column is the phase, usually three phase, but yeah, especially the small ones, small what you call small generators that are single phase also. But in this case, I only have three phase bigger generator sets. Okay, then okay, then also have a portion for the staff. Okay, I've utilized mechanic here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 mechanics. This is generator mechanics that are going to be conducting or performing the preventive maintenance, corrective maintenance, or the major repairs. Okay, I have staff number from 11 to 25. Then electrician are a few guys. There are only five of them. I have staff number from 26 to 30. And then, of course, there's only one operations manager, which is okay, fixed in this area here, Gregory Black. And then going back to the dashboard, okay, what else do we have here? Okay, work instruction. Okay, the work instruction is important as well. Okay, this is the standard operating procedure. Okay. Let me go into the first one, to the first line. Okay, this is the work instruction, the standard maintenance procedure, SOP, standard operating procedures, where proper handling, operation, and maintenance of the generator set should be done properly and safely. Okay, what are the things that we're going to be avoiding here? We avoid accident, incident, physical injuries. We avoid fire hazards. We avoid damaging the unit or the asset. So we have to make sure that these procedures are implemented. Okay. So the first one is if a warning tag is attached to the engine start switch or to the controls, do not start the engine, remove the control, consult with the person that attached the warning tag before the engine started. There are some other workers working in the control panels, in the switchboards, some other equipment, remote from the generator set. So you have to talk to those guys. There's a reason why they put lockout tagout on the unit. They don't want the unit to be started by somebody. So you don't want to start that unit. Otherwise, that would be very dangerous. And then let's go to the next one. The next one is all protective guards and all protective covers must be installed if the engine. So before you carry out the preventive maintenance or the corrective maintenance, you make sure that you do all these things. This is for your safety and the safety of the unit. So all protective guards and all protective covers must be installed if the engine must be started in order to perform service procedures. Okay, that's what I was saying. So to help prevent an accident that is caused Buy parts in rotation, work around the parts carefully. Okay, now start the engine from the operator's compartment or from the engine start switch. Then always start the engine according to the procedure that is described in the operation and maintenance manual. Knowing the correct procedure will help to prevent major damage to the engine components. Knowing the procedure will also help to prevent personal injury. Okay, let's make this faster. To avoid overheating of the engine, accelerated wear of the engine components, stop the engine according to the operation and maintenance manual. Okay? So stopping the engine immediately after it has been working under load can result in overheating and accelerated wear of the engine components. See, when you unload the power to the users, let's say for industrial plant or military installations or power plant, you have to cool down the engine. You have to run the engine without the load to cool down the engine, the cooling system, the lubrication system, the charging system, all the system of the engine should be cooled down in order to, as I stated here, you have to, cool down working under load so that you prevent the overheating of the engine and accelerated wear of the engine components. So avoid accelerating the engine prior to shutting it down. Avoiding hot engine shutdowns will maximize turbocharger shaft and bearing life. Then use the emergency stop button if equipped only in an emergency situation. There's a red button which says emergency stop button. You don't use that for normal operation, okay? Like normal shutting down of engine, shutting off of engine, generator, okay? The red button, emergency stop button, is only used in an emergency situation, okay? Next is on an initial startup of new engine that has been serviced, make provisions to stop the engine if an overspeed condition occurs. To stop an electronic control engine, cut the power to the engine and or the air supply to the engine. Why air supply? Some starting motor not only using in terms of the electricity from the battery. Some bigger generating sets, they're using pneumatics, air pressure to start the starting motor, which is pneumatic also. Okay. Let's go to the next one. To relieve the pressure from the coolant system, turn off the engine. Allow the cooling system pressure cap to cool. Remove the cooling system pressure cap slowly in order to relieve the pressure. You have to relieve the pressure, very important. This is for the safety purpose. And then to relieve the pressure from the fuel system, turn off the engine. Very important, turn off the engine. And then to relieve pressure from the lubricating system, turn off the engine as well. And then change oil and filters should be done every 6 months. This is for, if the generator is seldom used, it's for standby unit set. However, if the generator is operated daily, it means prime power utilization, say 8 to 12 hours daily, then change oil and filter every 3 months, or depending on the result of the used oil analysis, like if the sulfur content is more than 1% or 1,500 operating hours, if the generator is operated to 8 to 12 hours daily. Okay, so I just specify here the indicated the period, which is 6 months or 3 months, but it's some installations, they are usually basing it on the service hours, change oil or change oil and filter. Used engine lubrication oil must be sent out to a laboratory for used oil analysis. Every change oil intervals like analysis should give report on the following: component wear rate, oil condition, oil contamination, and identification of oil. Okay, engine lubrication oil additives can be added. It can also be added, no? Especially if the engine is consuming more oil, then you can add additives, especially for older engines, to slow down the wearing of engine parts such as main bearings, connecting rod bearings, piston rings, valves, camshaft bushing, etc. Contact your manufacturer or supplier for the appropriate engine oil additives. Okay, this is all for safety for you and the unit safety. Engine cooling system must be added with 50% ethylene glycol. This is it's sometimes the color is green, right? 50% 50% water, 50% ethylene glycol. Why not 100% water? To avoid rust, corrosions, etc. So you have to, ethylene glycol is good for prevention of rust and corrosion, but it's also not good 100% ethylene glycol, because it will eat up some components, especially those that are aluminum uh, type of components, or even the cast iron type of metal. This is bad for the metal, the ethylene glycol 100%. So it should only be 50%. So 50% glycol, 50% water. Inhibitor for especially antifreeze for those generators located in the North America, in Europe, which is the weather, or the climate is freezing condition. So you need an antifreeze type of coolant. So for the purpose of increasing the boiling point temperature, the boiling point of water is like 100 degrees Celsius, right, for the water. But when you put ethylene glycol, the boiling point will go up, because the boiling point of ethylene glycol is much higher. I'm not sure, but I think it's around 300 degrees Celsius. I'm not sure about that. It's a long time. I have, sometimes I forget. So ethylene glycol is much, much higher when it comes to boiling point. That's why it's good for the boiling point. That's why the engine does not, the temperature does not go up, suddenly, because of the ethylene glycol, which is having a higher boiling point. So the engine does not overheat easily, especially during the summer heat. It will also serve as an anti-freeze solution in extreme cold weather condition. Remove the engine load, reduce the engine RPM to low idle, then allow the engine to idle for 5 minutes to cool down. Okay. Look in the service manual for the engine oil refill capacities of the engine oil sump. Never disconnect any charging unit, circuit, or battery circuit from the battery when the charging unit is operating. A spark can cause combustible gases that are produced by some batteries to ignite, or very dangerous. This is uh, risk of explosion, okay, or risk of combustion or fire hazard, okay. So to help prevent sparks from igniting combustible gases that are produced by some batteries, the negative cables should be connected last from the external power source to the negative terminal of the starting motor. If the starting motor is not equipped with the negative terminal, connect the cable to the engine block. Okay? So the frame of the generator set can also be used as a ground, usually the negative side of the batteries. Some batteries are having 24 volts battery, two batteries 12 volts connected in series connection. That would make it 24 volts, because bigger engines needs bigger power of the starting motor. That's why they need more, the uh, the uh, the ampere hour is higher for the battery like this, turning the starting motor to start the engine. So the terminal can be connected to the engine block, okay? So to the frame, and the frame of the generator usually are being earth ground. There's a harness connected to the frame, and the other end of the harness connected to the or buried in the earth, okay, in the soil, okay, for ground purposes. All right. And then check the electrical wires daily that are loose or frayed. Tighten all loose electrical connections before the engine is started. Repair all frayed electrical wires before the engine is started. We're almost done here. A few items left. Correct grounding for the engine electrical system is necessary for optimum engine performance and reliability. Incorrect grounding will result in uncontrolled electrical circuit paths and in a reliable electrical circuit paths. One of the danger here is the electricity will also flow into the crankshaft or the bearing journal. So they are also conductors. So this is bad for the components, you know. So make sure that your ground is done properly. So engines that are installed without engine to frame ground stops can be damaged by electrical discharge. Okay. Generator isolator for maintenance. Okay, when you're doing maintenance, you have to isolate the generator. You know, you stop the engine, attach, do not operate. It's lockout tagout procedure, you know, or similar warning tag to the engine starting circuit and disconnect the engine starting circuit. You know, you have to implement the lockout tagout procedure for this. Okay, disconnect the generator from the distribution system, lock out the circuit breaker. This is what I've said, no, lock out, tag out. You know, they are like a padlock. It's not enough that you turn off the circuit breaker. You also have to, you know, to padlock circuit breaker and put a tag, you know, lock out, tag out. Remove, you know, remove transformers fuses for the circuitry in terms of the power, sensing, and control. Attach a do not operate warning tag to the generator excitation controls. Remove the cover of the generator terminals box. Use an audio-visual proximity tester. You have to test in order to verify that the generator is de-energized. Remember, this is 400 volts or 80 volts. The amperes is very high. And this is a three-phase, maybe 3 bars. So very dangerous for electrocution or electric shock, okay? Or arc flash, arc blast, okay? So this is for your own safety, okay? This tester must be insulated for the proper voltage rating. So the tester must be insulated for proper voltage rating. Follow all guidelines in order to verify that the tester is operational. You have to make sure that the tester is really operational. Because if you're doing testing, it's not giving you readings, then you are in precarious situation because you are not sure whether the generator is de-energized or not, and that is very dangerous, a high risk situation. So determine that the generator is in de-energized condition. Add ground straps to the conductor's terminal during the engine work period. This ground strap must remain connected to the conductors and the terminals. Okay, that's all about the work instruction or standard operating procedures when you are performing the maintenance procedure of the generating sets. Okay. Okay, I think I have presented everything here. Okay. What about the PM plan? Did I present this already? Okay, I have said, right, that these are the things that you're going to be doing under the preventive maintenance service. Okay, these are the item description, the things that you're going to be doing, the mechanic is doing rather. And then the frequency, there are daily 500 hours, 1,000 hours frequency of servicing, which is under the preventive maintenance service of PMS. Okay, now we're gonna start doing our job now. Okay, maintenance department. So I have done an automation of this. Whenever I fill out the job order, then I add the data. It will go directly to the job history here, right here. Okay, we're gonna find out now. So let's start by doing the genset. Okay. See, I show you the master list, genset 1, number 1, all the way to number 20. So we start with GS1. Okay, automatic. You have all the specifications here. So what is the job type? Okay, we'll be doing preventive maintenance service, that's PMS. So that would be preventive maintenance service. So let's just assume that you're gonna start from scratch and you're gonna start from 001 as our job order number. Let's say that the job is gonna be done on 1st of November, or rather, let's say 1st November. Okay, 1st November. Okay, this is the same thing. GS1 is the number. I have list of the job type here from PS1 all the way to MR4. No? C1, C2 up to 16, MR1, M1 to M4 for the major repair. So let's just assume they're gonna be doing the P1, which is the engine assembly, which is the inspection, work around. Okay, okay, I changed my mind. We're gonna be doing this because this is daily. If you look at the PM plan, that is daily. I want to start from the, okay, I'm gonna be doing, let's say for 15, for example, to 50 hours. Okay, I'm gonna start from 17, initial 500 hours, all the 500 hours I'm gonna be doing that. So I'll go back to job order. So I'm gonna be doing, what did I say? 17? Or you can type also here. You can type P17, enter. Okay. Colon sample. I don't want that. It's only sample. Okay. Let's say okay, I'm gonna start from 18. Engine blah blast. Okay, engine blah blast, check. Okay, I'm gonna assign a mechanic for this. So I'm gonna select 11. Remember here, I have a list of mechanics here, and let me show you again. So stop, mechanic. Okay, the stop number, and the electrician. Okay, go to the job order. Okay, now let's get the mechanic 11. The first guy on the list, 11, who is Robert Smith. Robert Smith, and this would be permanent because this we only have one operations manager unless we are gonna replace this guy, but it's gonna be permanent here. Okay, so what we're gonna do is this is engine blah, so this is mechanical work. I'm not gonna assign an electrician for this job. So let's just add this data. Okay, then go back to the job history. Okay, now we have the information here. Okay, job order number. It's gonna be done on November 1st. The genset number, equipment number is GS01, Caterpillar. Okay, these are the information. And the job is the PMS, code 18, engine blah, check. And who's the guy is going to be doing this? Robert Smith. Okay, Western guy. Okay, Robert Smith, staff number 11. Okay, go back to job order. Okay, so we have that. Let's say that we have another job for the same job order and the same genset number. So we'll just add new record. Okay, job add new record. Then it's same number, same job, which is type is PMS. Okay, we say we are gonna be doing this on November, sorry, not November, 001 here, November 1st. And then we say, when was that? What was the job? The job was, where's the number? P18. Okay, let's say, okay, we're gonna be doing the P19, the next one. P19, this one. Oh, battery electrolyte level, check. Or maybe adding, top up. electrolyte level, battery solutions, okay? A mixture of distilled water and sulfuric acid. That would be battery solution, no? Battery electrolyte level. So let's assign that to not to mechanic because this is electrical work. This is electrician's work, battery. So I'm gonna assign this to step number 26, which is who is Ronald Martin. Ronald Martin. All right. Okay, you add the data. Go to the dashboard to the job history. Okay, we have the second history here. Okay, what would be the job? Preventive maintenance, battery electrolyte level check, and assigned to Ronald Martin, number 26. All right, go back to job order. All right, so one more time. We'll be doing it, giving it to GS01 TMS. Okay, 001 11 first, and then give it to, let's say, P20, which is belt inspect, adjust, replace. Oh, this is okay, this is mechanical, so we're going to give it to, let's say, number 12, William Bell. Okay, mechanic, assigned mechanic. Okay, add data, new record, and then again TMS 001. Okay, 11-1, then maybe 21. Engine clean element, inspect, clean, replace. I'm going to assign this to same guy, William Bell. Okay. Then add data. Then new record. Okay. We're gonna do another job order GS for GS number 2. This is Detroit diesel 16 cylinder 149 series turbocharged intercooled, which is having a 1600 horsepower, 1200 kVA. Okay, so job type for this one, I'm gonna put PMS, then 002, then the date is 11/2. Let's say we're gonna do P23 engine oil and filter chains. Okay, I'm gonna assign to still the same guy. Can do it, or okay, or we'll give it to Ricky Brown, number 13. All right, and then add data again, then new record. Okay, this time we're gonna be doing for generating set number 13, Caterpillar C175-16. This time around, I'm gonna be doing CMS, corrective maintenance service. And this is 003. And we're gonna do it on the 3rd of November. So we're gonna go for the CMS. What is the CMS one? Well, let's say we are going to do the CMS one. The C1, which is drive belt replace. We'll choose another one. Water pump repair or replace, for example. Okay, assign it to number 14, who is Anthony Boyd. Okay, this is mechanical in nature, so this is for mechanic job. Then add data, then new record, then let's say GS05 or 04, number 4, Cummins engine, KTA 50. Okay, job type is again another CMS. Job number is 004. What was the last number? Let me check. 03. So, okay, 04 is okay. Okay, 04. Then 11, we're gonna be doing it in 11/5, November 5th. Then we're gonna be doing CMS. So CMS would be C5, for example. Engine alternator, overhaul, replace brush. This is electrical work. So this is the work of an electrician. So I'm gonna assign it to electrician number 27, which is Boyd Reynolds. I don't know, maybe 28, or Devin Bell, etc. Doesn't matter. So whoever is available, you assign it to him. There are only 5 electrician anyway, and 25 mechanics. 25 or 15, I forgot. Okay, then add data. Okay. Okay, what we're gonna do is we're gonna be doing the let's say this one. We're gonna be doing a Caterpillar C3 or 32. We're gonna be doing a major repair. Let's say MR, major repair. So 006. Again, we're gonna be doing in November 6, for example. So we're gonna be doing engine overhauling. What is engine overhauling? M1, right? Oh, major overhaul. Okay. I'm gonna assign this to number 15, guy. Mel Banner. And okay, when it comes to major overhaul engine, there are also uh, electrical system that's going to be done, like removal of starter motor, checking of starter motor, charging system, alternator, engine alternator, etc. So you need to assign another guy, uh, B29 guy, or Larry Bryan, okay, to do the electrical side of the major overhauling, because it will involve electrician. Okay, we have to have add data. Yeah, new. Okay, the same thing. Which one is that? I forgot. I forgot the number that we use. Uh, GS05. Okay, same unit 05. Because what we're gonna do is this is major repair as well. Okay, major repair. What was the job order number? Okay, we can always check. Job order number 06. So going back there, so we say 06. Okay, and then I think, let me see the date. The date was November 6, or the same, or not the same date, because you're gonna do overhauling. Maybe it will take you 3 days or 4 days, 5 days. Say 11/6. I'm going to put this 11/10, November 10. What is the code? The code is M3, or dynamometer test. So after doing the engine overhauling, we're gonna put the engine to the dynamometer test room for the testing of the engine, for to determine the brake horsepower. Remember, brake horsepower and the engine torque. Okay. Okay. The same guy. Who's that guy? Brad. I don't think that was Bradford. Let me check. You can always check, no problem. So the guy who's done the overhauling was Mel Banner, number 15. So Mel Banner, and no need for electrician. Okay. Only mechanic can do the job in dynamometer testing. Okay. So Mel Banner is with you. What is the number? I forget the number. Sorry. We have 15. Okay, no need for electrician. So we have to add. Okay. Complete. We have complete. Okay, sample here. So this list will be will become bigger list as the days goes by, as the period goes by, because you're doing every day, you're doing a job order, This job order will also increase. Okay. All right. So with this table, this information, you can also generate a what you call, you can generate pivot chart, you know. You can also generate pivot chart from this table, or pivot table, or pivot chart rather. So that is good. So because we have all the information. What's lacking here that I did not include is the costing side, you know, because I don't want to make it longer. The next time when I'll be doing the preventive maintenance for vehicles using this format, then okay, we will include the spare parts that is utilized for the repair, belt, water pump, oil pump. How much would be the price of the costing side? We'll also include that here. Okay, so we go to the dashboard. Okay, so this is it. This is my presentation of my program, the prime power generator set. Okay, I hope you like this presentation, that it will help you, doing your own preventive maintenance program. Okay, for the generator set. So I have done the preventive maintenance creation for heavy equipment. I have done this now today, the generator. The next time around, I'm going to be doing the vehicle preventive maintenance program. I'm gonna do it more comprehensive, including the whatever cost or spare parts components that incurred on this preventive maintenance program that be included in the analysis. Okay, so I hope you like this. I like you like this. Actually, I have included this. If you are wondering what is this ice, oh, it's anyway. This ice is like showing the ribbon and then hiding the ribbon. Oh, it's under the BBA macros. Okay. So I hope you like this presentation, and this is good for you. You can implement this to your own operation in your doing hundreds of generator set. Maybe you are maintaining four uh, megawatt generator set, maybe 20 generator set in one side. Maybe 10 is being synchronized. One generator is having 4 megawatt, 5 megawatt, 6 megawatt, etc. 16 cylinder, 20 cylinder, 24 cylinders engine, bigger one, heavy duty generating sets. So I hope you like this presentation. If you do, please like and share, and you can also subscribe and hit the notification bell so that you'll be notified, because I'm planning more frequently uploading more presentation like this, so that you will learn from me in maintaining your fleet in doing your fleet maintenance, doing other things like distribution and logistics, warehousing operation, etc. I might be uploading this kind of presentation as well. So thank you for watching.